find the equation of a line, and you know that there's a point on the line, let's call it 1, 2, 3, whatever it is, and you've been told that the line is parallel to some other line. So maybe it's parallel to, if they write the line in this format, then what we need for the equation of a line is a point and the direction vector. Now, if you're parallel to this line, you can suck out of that the direction vector, 2, 5, -3. And since your guy is parallel to that, your guy can also use that as its direction vector.
Okay.
So your solution to that question would be 1 plus 2t, 2 plus 5t, and 3 minus 3t, and that would be it. Now,
Okay.
suppose you're still wanting the equation of a line, but it's perpendicular to a plane. Let's say it's perpendicular to the plane 3x minus y plus 2z equals 11. And we'll assume that you know the point 1, 2, 3 again. Then we should be able to find the direction vector, because if you have a line and the plane is perpendicular to the line, then won't the normal of that plane be parallel to the line?
Yes.
So that's the trick. We're using the fact that we know that the normal to a plane is perpendicular to the plane. And if the line that we want is also perpendicular to the plane, we then can make the assumption that both of those are parallel to each other. And that means that we can get our direction vector by pulling it out of here, 3, -1, and 2. And so the equation of our line will be 1 plus 3t, 2 minus 1t, and 3 plus 2t. So there's an equation of a line when you're told it's parallel to some other line, and we get the direction vector by using the components of the t's, which tells us the direction. If you're given or asked to find the equation of a line perpendicular to a plane, then we can get the direction vector by using the normal to that plane, because of the argument that the normal to a plane will be parallel to a line that's perpendicular to it.
Okay. Would it ever ask us how to find the equation of a line if it's perpendicular to a line? Do we know how to figure that out, or?
Not enough information.
Okay.
Because if you think about it, here's a line. If I tell you my line is perpendicular to it, there's a whole rotation of lines.
Yeah.
That would do that. Now, what they could say is it's perpendicular to 2 different lines.
Okay, and then you'd cross product.
And you do a cross product, so you could get it that way.
Okay.
Right?
And then for the plane one, it would never no, it does ask us, huh? If we can find the equation of a line that's parallel to the plane. Can we?
Yes. So you want the equation of a line that's parallel to the plane. That's not possible unless there's more information, because if you imagine this piece of paper as a plane, this pen is parallel to it, but aren't all these orientations also parallel to it? It's not unique.
Okay.
So there must be more information than just it's parallel to this other plane.
Okay. That makes sense.
Does it give any more information apart from that? I mean, if you give me enough information, we can find that for sure. But we need more.
Okay, good. I was they just all seemed too easy. And I guess I just didn't think about the fact that the line in the plane, that, that was part of the question. So that makes a lot of sense.
Okay.
And I don't know, do we take turns? Because Tim's here too. Does Tim ask a
Yes, why
question?
not? That seems to be a fair way sharing of time. Tim, what you got for us?
The same exact question, except for one little thing.
Yes.
Wait 1 second. Let me. There we go. What if they gave us the points in? What if they gave us? So I wanted to find a. Is it a line through a point? It wants us to have it perpendicular to IJ and JK. Would I just
Okay.
take? Would I just take the 2 points and then make them write them into whatever the heck it's called format?
Okay, so if I'm getting you right, the guy you want is perpendicular. So it's a line. And it's
Yeah.
going to be perpendicular to I and
IJ
J. And the
Yeah,
other
and-
one is J and K, right?
Yep.
One of the reasons I hate this notation is that it just,
It
in my brain,
doesn't fill out the 0.
it doesn't fill out the zero, and it's very helpful in my brain to see the zeros. Now, if you are perpendicular to these two, then won't your direction vector be the cross product of these two?
Yes.
So now you've got your direction vector. Now, all you need now is some point on the line. Do they give you the coordinates?
Yeah, they give you a point. I think it's like 0. It's 440.
Right,
Although,
so
I mean, I think
whatever it
any point
happens
would
to
work
be,
for me.
right? I'm just using 1, 2, 3 today, right? But whatever it happens to be. Now, that guy there is a direction vector. Now, I have no idea what the answer is, but let's pretend it's 1, 1, 1, you know, just for argument's sake. Then you could get the equation of your line. It's 4 plus 1t. It's 4 plus 1t. And it's nothing plus a t, if that's what you got.
Great.
If that's 2, 3, 4, then you'd have 2t, 3t, and 4t.
I just wanted to make sure that it was. I thought it would be the dot product, but I'm out of guesses.
Right, dot product is going to give you a scalar, right, a single value. And that's never going to be helpful if you're interested in finding the direction vector.
Okay.
So
I
would
meant
keep
cross
away
product.
from the dot. Yeah, the dot product is useful when you want to know the angle between vectors, because the angle is a scalar and the dot product generates scalars. But if you know the answer, the thing you're needing to get the answer is a vector. Keep away from the dot product. It's not going to be a good direction to go.
Thank you very much. That was actually my question.
Okay, we're back to you, Tessa. What you got?
I couldn't make ups or downs with number 13. I went back to the book and everything, and I just got more confused. I spent
Okay,
a lot of time
is it
on
something
too.
you can read out to me quickly or share the
Yeah.
screen with or whatever?
Yeah, find a vector function that represents the curve of intersection of the two surfaces, the paraboloid z equals 3x squared plus y squared, and the parabolic cylinder y equals 6x squared.
Okay. Now, if you put those guys into something like 3D GeoBra, whatever the damn thing's called, you'll be able to see them. You can just tell me, you can just trust me that they intersect on a curve, right? And we're trying to find the equation of that space curve. So it's basically got an X, a Y, and a Z component. And our job is to figure out what X, Y, and Z are in terms of T, right? Space curves use T as time. So I'm going to look at this equation, equation 2. And because it's only got 2 variables on it, I'm focusing on this one. And I am going to make X equals T. And if I say X is T, then won't Y, because it's 6X squared, be 6T squared. So now I know this guy's T. I know this guy is 6T squared. Now you might think, well, why did you pick X equals T? I could have picked Y T or Z T. You try and pick things that have a natural flow to them. Would you agree that if you make X equals T, isn't Y pretty nice to find?
Yeah.
If I switched it round, I could get an answer, but wouldn't I have T equals 6X squared? Then wouldn't that just look really ugly and really messy? So it's to do with these. Now you say, but we're missing one. Yeah, you're right. I now know that Z is 3X squared plus 3y squared, which means it's 3t squared plus 6t squared, which is
Squared.
9t squared.
Would it be
Check that.
6t squared squared?
6t squared.
Oh, no, or
No, yeah, you're right.
Okay.
So it would be 3t squared plus 36t to the 4. Now, of course, that is the equation of the space curve of the intersection of those two surfaces, but it is not unique. I deliberately chose x equals t because in my brain that looked like the natural choice. If I decided to make y as t, can you imagine x would be an ugly square root with 6 in it somewhere? And could you then imagine that this would be a different, uglier version of z? And so you would end up with different components here, here, and here. Now, I hope Weber sign is adaptable enough to pick one of the other choices that could have happened. But normally, there tends to be a kind of obvious candidate, right? So, making one totally off the top of my head, suppose you were told you're taking a sphere, which is that guy, surface of a sphere, and it's going to intersect with that guy. In fact, let's make it more interesting. Going to intersect with that guy, right? So first thing you do is you pick the equation that only has 2 variables. If both equations have 3 variables, you're in real trouble because the algebra is really ugly to make it work. So you're pretty much guaranteed one of them at least is going to have 2 variables in it. So I'm going to pick that one. Now, looking at that one, who would be the candidate for making t? The y guy or the z guy?
the Z guy.
Yes. And so you make z equals t. That makes y 2t squared plus 1. So how do I get x? Well, x squared plus y squared plus z squared equals 9. And then you do a whole load of algebra, and when you're finished, you're probably going to have a square root, probably a plus and minus, with a whole load of ugly t's in it. But at least 2 out of the 3 were nice.
Okay. When I looked this up in the book to try to get a little insight into what to do, it had some weird like cosine stuff. Like I don't know. It was kind of a similar one with a paraboloid, but I think a line intersected the paraboloid. And their x, y, and z values were like, I don't know, there was like cosines. Does that sound familiar? Or?
It does. It might. I'm making up my own version here. I don't know what it is, right? Whatever, right? That would be a cylinder meeting up with a plane, right? What they're doing is they're using this guy, and you're able to say 3 sine t and y is 3 cosine t. Can you see why that combination generates 9? Right, let's do it. The 3 comes from the 9, right? If you take this guy and you square it, you get 9 sine squareds. If you take this fella, you get 9 cos squareds.
Oh, yes.
That's why you got 9. So they're just using a trig identity to generate 2 of them. Now, once you know 2 of them, can't you get whatever the missing one is, right?
Yes.
So if they had an x squared plus y squared equals 10 or 4 or 42, they may have went on this direction here. Now, what you can then do is, once you know x and y, couldn't you just go here and say y is x had z? So 3 cosine t's is 3 sine t's plus z. So won't 3 cosine t take away 3 sine t be my z, and we are good to go.
Okay. Is that the only way to solve that, or is
No.
there a way to do it without?
This one you could do it like this. Well, I take that back. You could take the two equations and you could make one of them t. The problem with that is that both those equations don't work well, but we could do it. Suppose I take that equation. At least it's got two variables in it, right?
Mhm.
So if I make x equals t, then can you trust me that y squared is that guy? And so that makes y technically plus or minus 9 minus t squared.
Mhm.
And now I know x and y, can't I plug it in here and get the z guys?
Right, yeah.
And would you agree that these don't have sines and cosines in them, and they are much clunkier because of the plus minus problem? But it still would be the correct answer. It would just be a totally different looking correct answer.
Okay, I see.